The first section, 9.4, was about sequences. A sequence of numbers could be something simple like 2, 4, 6, 8, 10. And in this sequence, I add 2 each time. And so if I was going to write a formula for the sequence, I would write, if I wanted to use the equation, I could write a sub n is equal to the first term plus the common difference times the number of terms, n minus 1. Or I could just figure that out. It's pretty easy. A sub n is equal to 2n. You just take the term, times it by 2, you get the next one. And so whether I use the fancy formula or whether I did it in my head, I still have this explicit formula for how I get the answer. The difference between a sequence and a series is a series has a sequence of numbers, but it adds them up. So the question might change. Instead of saying what is the first 5 terms, it might say what is the sum of the first 5 terms. They use new notation. This symbol is a summation symbol, and when you see this symbol, you should think of it as saying, what is the sum of? And then it will have an equation. Like for this problem, the equation is 2n. But I can't just add up 2n. I have to tell which numbers to add up. So it's going to say from n is equal to 1 for the first term to n is equal to 5 for the last term. So this now says, what is the sum of the first, second, third, fourth, and fifth term if the formula for the sequence is 2n? So if you were to look at the summation notation and go from the beginning, you would look here first at the 1, and you put a 1 in for n, and that would give you 2. And then you'd put 2 in for n and get 4, and then put 3 in for n and get 6, and you get 8 and you get 10. But instead of just stopping with the sequence of numbers, it'll ask you what the sum of the sequence is. That's 2 plus 4 plus 6 plus 8 plus 10. And that happens to be 30. It's also pretty nice to know how to generate sequences and series on your calculator. And whenever I take a video of my calculator in this program, it crashes the upload, so we're just going to describe it. Take out your graphing calculator and hit second clear. So the graphing calculator is cleared. And I'm going to do the same problem. I'm going to do the sum from n equals 1 to n equals 5 of the sequence 2n. And how I use my calculator to do this is I hit the second button and then the stat button, and that will pull up the list menu. I'm going to arrow over to ops, and I'm going to arrow down to sequence, and I'm going to hit enter. When I do that, a parentheses comes up. I'm going to fill it in like this. My formula is 2x. I'm going to put that formula in for x. This is just part of the calculator notation. I'm going to do it for the numbers 1 through 5. If you type it in like this and then hit enter, and if you're doing this for other problems, this x always stays x, but this part right here is where your explicit formula goes. And right here is how many terms you will need. So 2x, comma x, comma 1, comma 5. And my calculator generates that list that we were talking about before. Hopefully you have a calculator in front of you and you can generate that list as well. On your calculator, if you did this correctly, your list should look like this. A bracket, 2, 4, 6, 8, 10. And now if you want the calculator to add this all up, you're going to type in second stat one more time, This time you're going to arrow over to math. Second stat, arrow over to math, arrow down to sum, and you're going to have the calculator type the sum, and it's going to have parentheses right here. And now you're going to hit the second button and answer, and the answer button is underneath the negative sign. And if you hit enter on this one, it should give you 30, just like last time. On the homework assignment, you will have 3 types of problems. The first type of problem will just be making sure you know how to use summation notation. So when you see something like this, can you, without a calculator, evaluate it? I'm going to go from k equals 1 to k equals 4, and I'm going to have my formula be 1 over n. So you'll need to know that this is actually 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, and to be able to evaluate that without a calculator. So for this problem, I'd get 12ths to be a common denominator. So I have 12 over 12 plus 6 over 12 plus 4 over 12 plus 3 over 12, and that is 25 over 12. And 12 goes into 5 2 and 1/12 times. You should also know that problems such as this will approach a limit, because since the number that I'm adding up gets smaller and smaller and smaller and smaller every time, eventually this is going to run out of, it's not going to be able to go past a certain number. A really famous math question is, what's the sum of the first 100 numbers? So if you were to add up to 1 plus 2 plus 3 plus 4 all the way up to 100, how would you do that? And a very famous mathematician named Gauss did this in his head when he was 10 years old. And if you'd like to try to follow in the footsteps of Gauss, pause the video for a minute and try to do that quickly in your head. So what Gauss noticed that there was pairs of numbers, and I'm not going to write out 100 pairs of numbers, so I'm going to try a smaller problem. I'm going to write out the sum of the numbers 1 to 10. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What he noticed is this pair, this pair, this pair, this pair, and this pair all add up to 11. And so he has, if we count my number of pairs, I've got 1, 2, 3, 4, 5. I had 10 numbers, but those 10 numbers resulted in 5 pairs. And those 5 pairs all had a sum of 11. And so the sum of the first 10 numbers is 55. Gauss extended that idea to the first 100 numbers. And so he was able to think through, well, I have 100 divided by 2 pairs whose sum is 101. And so 50 times 101, or in this case, the sum of the first 100 numbers, is 5,050. Now, we've formalized that in this section to a summation formula. And the summation formula for arithmetic series looks like this. The sum of an arithmetic series from k equals 1 to n is equal to the number of terms in the series times the first term plus the last term divided by 2. And you can thank Gauss for that formula. The second formula we're going to use today is for the sum of a finite geometric sequence. And so let's take a look at a geometric sequence. Let's say we start off with, let's do 3 times 2 is 6 times 2 is 12 times 2 is 24 times 2 is 48. And let's say I want to find the sum from k equals 1 to k equals 5 of the first term is 3 times 2 to the n minus 1 power. Okay, that's what that looks like in summation notation. Oh, I think I forgot to say that this is called summation notation, but that actual Greek letter is sigma, the capital sigma. And so what I'm doing in this problem is I'm taking 3 plus 6 plus 12 plus 24 plus 48. Now I don't have a fancy story for the mathematician behind this one, but the formula for the sum of a geometric sequence is the first term times 1 minus r to the n over 1 minus r. And although I'm not always a big fan of memorization of formulas, the formulas in section 9.4 and section 9.5, you will need to have them memorized for both the quiz and for the test. The reason being that this class is designed to prepare you to take the AP Calculus test, and you're going to have to know how to do these things on the AP Calc test without a formula sheet to help you. So let's finish this problem by taking a look at how we would use the formula to solve it. So obviously I could just add up the numbers, but when I have a larger sum to take, it's useful to be able to use the formula. So to get this answer, we would first take the first term, 3, times 1 minus the common ratio. Notice in this problem I'm multiplying by 2, so it's 2 to the 5th power over 1 minus 2. So this is going to be 3 times 1 minus 32, negative 31, divided by negative 1. 3 times 31 is equal to 93. Now you can verify for yourself on a calculator that 3 plus 6 plus 12 plus 24 plus 48 is equal to 93. But you'll sometimes be finding sums of larger terms than just this, so you'll need to use the formula on some questions. You can actually stop watching the video now. I'm just going to do a couple more examples that sort of put things together. Like let's say you had this formula, the sum from n equals 1 to n equals 11 of, let's say 2 plus 3 times n minus 1. Well, first of all, you need to know how to read this. And so when I read this statement, I actually personally find it easier to simplify that first. That's 2 plus 3n minus 3. That's 3n minus 1. I know that's the black notation is how they give it in the book, but I kind of like looking at it like lines better. And so if I go and I put in the number 1, I get 2. And if I put in the number 2, I get 5. And 8 and 11 and so on. And I'm finding the sum of these first 11 letters. So I'm actually being bad right here. Because this is a series, I need to write this as 2 plus 5 plus 8 plus, and you can at this point go dot, 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 plus the last term. The last term is going to be 33 minus 1, 32. So you're finding the sum of the first 11 terms. And you could add them all up, but if you would like to use our nifty new formula, the nifty new formula says the sum is equal to the number of terms, 11 divided by 2, times the first term plus the last term. So if I add them all up, that's 5.5 times 34, and 5.5 times 34 is 187. Now, take a second to verify that in your calculator. If you type in your calculator sequence 3x minus 1 comma x comma 1 comma 11, your calculator should generate the right sequence to give you all of those numbers. 3x minus 1 comma x comma 1 comma 11. Got all my numbers? And then I do sum of the answer. So, second stat, arrow over to math, sum of the answer, and I can verify my answer is 187. So you need to know how to read this notation, how to use this notation to generate a series, how to add up a series using the summation formula for the series. And you actually don't have to know the calculator stuff, but I think it's actually, if you remember it, is pretty useful on standardized tests, because that's a really typical ACT and SAT question, and it's nice on those to have a calculator. Since you guys aren't like terribly familiar with summation notation, why don't you try writing this sequence in summation notation? And if you need to hit pause, go ahead. 6 plus 3 plus 3 halves plus 3/4 dot 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 to infinity. First of all, decide if it's arithmetic or geometric. I'm not adding or subtracting. Like here I subtract 3 and here I subtract 1.5. So there's not a common difference. Since it doesn't have a common difference, I try something else. It looks like that this is a half problem. 3 is half of 6, and 3 halves is half of 3, and 3/4 is half of 3 halves. So this number right here, 1/2, is my common ratio. And the formula for a common ratio is the first term times the common ratio to the n minus 1 power. And I want to find the sum from the first term. Oh, I used n, so I've got to use n. From the first term all the way to infinity. Now, some of these types of problems will get bigger forever and ever and ever. But other problems like this, like if I take a half each time, it's just going to get smaller and smaller and smaller, and it's going to do what's called converging. And you might try this on your calculator, or just try adding for a while and see what number it converges to as an exercise. Let me know at the beginning of class.